Hi, good afternoon. So today we are going to start our next session on Java and full stack training. So we'll go through the hashing, and in our last class we were trying to optimize it to get reusable printing component instead of repeating the code. So we'll just quickly go through what we did in last class and then we will move ahead. So most important thing we accomplished was understanding the comparable and comparator interface. So Java provides the sorted, automatic sorting, but we need to tell Java on what basis it has to sort the attributes for the user defined class, which means if anything which is string or which is integer which is known to Java, it will go with the natural ordering or a natural sorting. But if we have our custom class, for example, we had taken the example of the student class, then we have to say on what order student can be sorted. It can be sorted either on the age or on some other parameter, whatever user defined. So how there is a way to tell a program how to do that, and that way is whatever domain object. So here student is a domain object. If you are working on a project where you have an employee, then the class employee would be called as the domain object, because that is what this entire thing is all about. Let's say the employee relationship project, so the core domain is employee. So the domain object is has to implement a comparable interface, which means that two objects would be compared on certain parameter, and that parameter you can define it inside here. So there were some limitation of this thing. So Java provided another way. What are the limitation? So first limitation is it can take care of only one attribute. So it can provide default sorting on the basis of one, but not multiple stuff. That's the first problem. And what was the second problem is, let's say today I am trying to consume some third party object which is not a domain object for me. For example, a student uses library, books. Now books, I have imported one jar or some package which some other author has written the program on book. So I need to do the sorting, and the book does not implement the comparable, and it does not have the implementation over there. So how would I do that? I am stuck, right? So there is another way. Whatever object is there, as long as you know what that object does and what attributes it has. Of course, it's exposed in the class itself, or sometime it's exposed in their API documentation. So from documentation, you can grab those fields, and then you can try other way, which is called as comparator. So comparator, any two objects of any, again it comes in two way. One is the generic and one is non-generic. Generic means if you do the student whatever object pass here, by default Java understands and it takes all the attributes for the same. But somehow if you are going with non-generic, which means if you take the object, then you have to explicitly cast it. This is called as casting. This is O1 and this is O2. It also works fine. Only issue it has, you have to do the casting. And sometime if it is not incompatible or there are some issues, then you might get some exceptions. So just to be on safe or a better programming way is to use the generics. So and we took the example, if there are some students and if we tell them to sort their stand in a height wise way, sort them in the height wise way, each student can compare itself with other student, like here. So here the student is the first object which is comparing it with the all other students to himself object. That's why this comparison happens over here. So this is that. But if teacher does that, then on different parameters, teacher has their mark sheet, teacher can see them physically, or teacher has some other aspects on which they have to compare. they can do a comparison between two students, and then we based on whatever criteria, and then they can give results. So we did it on two ways. First is we compared it on the basis of the string, like the name. So we called it as a name comparator. It implements comparator generic way, and we just leverage the compare to method of string, which provides us the way -1 +1 or 0, what we have done it over here manually. We compared the age. So this was been done in very detailed yesterday. This is just a small recap of how it does, and we were able to run all these programs. Now, as far as the homework or the assignment is concerned from last time, is first we need to figure out a way to make it simple. So let me just see the PRs if someone has already achieved that. First, let's merge this pull request. Now we'll go with Naren P. So he has list underscore collections. I am not sure if Naren is coming from JavaScript background or Python background, but there in Python they use underscore in class conventions, but in Java it is always the camel case. Of course, the camel case, but they avoid doing or using underscores in the class names. However, in variable also they avoid, but in variable one can do it. Instead of doing very underscore, they will do camel case. And what is camel case is, so if I have to write employee relation officer, this can be written as employee underscore relation underscore officer. So different language have different ways basically. Python or JavaScript, or some people might tend to use underscore to do the separation. In Java, they have a convention that if it's uppercase, then this is entire different word. And then if it's a method, they will try to name it like this. But if it is a class, they will try to say start with the capital letter. Employee, employee domain object, something like that. It could be a public class. So this is good. We can leave the comment. There are Java coding standards or best practices. There is a style guide. So they have terminology, source file structure, formatting, how you need to have braces. Then you have naming. So camel case defined. Here they call it as camel case. Let's go with the naming first. So naming has the rules. Now how should you make the identifier? And class name. So class name are written as uppercase, upper camel case, the way I just told you. And the method can be written as like this. It has to start with lower case, and then it follows the camel case. But the class always starts with the uppercase camel case. And if it's a constant, it will always remain as a uh, all uppercase. There, since everything is uppercase, there is no way how to figure out next word. Then they can use underscore for separation. And they have given the example of constant, which is a final, static final. And why they made it static here? Because constant is not going to change no matter what object state is there. That's why we call it as constant. So they make it as static. And once they use the final keyword, which means whenever you are trying to instantiate the value, that value would remain same. You cannot change. That's why they call it as constant. Let's say the value of gravity is 9.81. So the value of gravity is same since millions of years, and till the time our universe would be there, I hope it would be same. It's not changing though. But with the sun getting depletion, there are some minor impacts on that. So just consider, finite our lifespan. So it is constant for now in our lifespan. It won't change. So that's how they do the constant as final data type, all uppercase, and then we make it a static. Non-static fields, everything else would go with the camel case, lower variable, all variables, everything else. So I'm going to put this in the PR. So after today's class, just try and go through this. And this would be for everybody though. So let me put it. And you can follow other coding guidelines. They are more or less pretty much similar, but Google has like more weightage on how things goes and happens. So you can blindly follow Google code Java style. It should be good. So you have this student list. That is fine. And another thing, what people say is your code should be like poetry, which means that it should be very readable. Whatever name variables you are naming or method you are naming, they have some other phenomena called as it should be verb, whatever method. So you know what is happening inside it. Because when you are trying to code it today, everything is in your mind. But after a month, even you will struggle, and if someone else is trying to read it, he should get the clear idea. Okay, what list is this? Is it a S list? So it could be the list of source list, or it could be student list, or it could be something else as well. So if we can name explicitly, like here what we did is student list, so it would be easy and readable throughout, because sometime we pass from this class to some other class, and inside that class if we have proper name it becomes easy. Otherwise it's hard to read, so try to make it like a poetry. The method names could be a little bigger, that is fine, but it is readable and understandable. Different philosophy. In Golang, they will not even go with big names or whatever. They'll just have one word, let's say S or Q or whatever, because there they are trying to optimize further. So they say why to consume 2 3 more bytes or whatever. They don't do it there. Different philosophy. In C also that's the same, but in Java they say that try to be descriptive, class name, file name, variable name, whatever, because there is minute performance gain, but if someone is not able to understand, there is a lot of time wastage or understanding wastage. Probably it can lead to the bugs also. So you have another class is set practice. S can be capital here, but that is fine. You have sets. So com.naren has a package called as sets, which is a sets of Java. Practice. Okay. This is the class. Inside the class, you're writing it in one. So another thing, since we are learning, and that's why. So instead of writing everything in main, usually programmers and the fresher programmers in any language, they will put everything inside one big method. And this method, this is about 50 lines or 60 lines. Sometime programmer write 200 lines or 500 lines of code, entire everything in the main. So we can avoid that, and then we can have small methods And since Java is designed in that way that you will call the method will do its job, then it is a return type, it is going to return back, and then once you get the return you can continue the linear flow. So let's try to understand that this is the linear flow. So what you did is you created one stack, and inside the stack you pushed some values, and then you are trying to pop some values, peek it, and doing something over here. So you can just extract this and make it a method called as stack operation. And then from here there would be one line method which would be called as stack operation. So as soon as control flow goes there, it will call that method and then come back here. Then it would go to the next line. In next line you can have whatever you want here. And third method you can call it here. Is this Purti's code? No, this is not Purti's code. Okay, you have some Dinesh and Navi. So try to not put very long. Ideally, one method is typically 15 lines code, should be. If it is more than that, then you can extract out a small method with its proper name, what it is doing, and then call it back. And it also helps while you're trying to debugging or you're facing problem. Why? Because if in this code anything will break or do null pointer anywhere, and in the logs you will say okay it's the main, and then if it's let's say 200 line, you have to go 200 line. But otherwise if the problem comes in this part of code, just this part whatever, and you get main, and then the method in exception it would say null pointer exception in occurred in the method called as hash set operation. So you know okay these are the just 4 5 lines of code or 10 line of code wherein hash set is getting some null pointer exception. So you don't have to go through or figure out the main whatever bigger code. So smaller chunk is easy to instantly identify which piece of code is giving the trouble. So this is in terms of learning the programming the right way and following the practice. So everything seems so far good, and we are going to return, sorry, merge it. So this has been merged. Now I have merged it, so our head will move ahead. Where is our head? So whatever in my machine, code would be from here because I have committed it yesterday after the session. And then you guys have got this much code on top of this. So if I'm trying to push, it's going to fail because the GitHub will say we don't know what code is there, how we can push it on top of this whatever. So it will tell me to pull it first before pushing. So I have to keep my repository in sync. Yesterday we were trying to push, but then it rejected, and it was saying that you have to do a pull, git pull. That's how when we did a pull, everything came in sync, and then we were able to push it. So let me do a git status. I have some files and some changes. Okay, let me first finish those stuff, and then we'll do a pull and push. So coming back here, the hashing part. So in the so uh, I believe Mohan might have gone through it, but it will take a lot of time to go through it. But in short, I'll just explain him what we did here is, and then we are going to optimize it. So he has to understand the problem. So we had we
Yeah, I have seen this morning.
okay. Then we'll just
I
go.
have one doubt, like, sir, if two objects having the same hash code, so how we can retrieve the values? Like here, so for Java books, we have used the same hash code. So if like we are having like 50 Java books, I have to specifically get some book with some title. How to retrieve that book is.
So what we are doing here is, of course, since we took the category, so multiple books are going to have the same hash code. So we are going to go into the bucket of that, and once we get into the bucket, we have to iterate. So we are iterating over here based on the bucket. So whatever thing goes in that bucket, that would come up. So hash code can be duplicate, and it will be duplicate mostly.
So if there are like 50 to 60 books, I want only the specific book, like how to
So
get it very fast. Is there any other way to
so
compare the books also?
now, the thing we have that if you have 1,000 books, you in the category you can get to the 50 books which are there. Otherwise, if you want, you might have to do the hash code based on more smaller stuff. That is called as indexing. So you mean you have to go just one book at a time, not a group. Here we are doing bucketing. Bucketing means that in 101, whatever books are there, they'll go inside this bucket. So instead of iterating over 1,000 books, you will iterate on that bucket, and bucket can have 50 books. But if you want further, stuff inside it, you can have another hash map, and inside that hash map, you can make the key as so what would be the unique thing in the book? Is it going to be the ID?
Like name of the book or something,
The name
or
of the
any
book can be
order of
duplicate or can be unique also. So then you can make another hash map which will have the string value here as I'll just show you. Will not you can try on your own the implementation, but just to understand, you will have another hash map which will be a string. And this would be the inner hash map. So what you are going to do is you will have a key and value would be your book, not the list. Further, what you will do that you have a list of books. So instead of putting the list of books, you will put the list of the map. So this is called as the map inside the map. Yes. So this will what we are going to do is inside the list instead of putting the books directly. Now you will try to put the map of the list. So next time, so you have two buckets. I will just try to show you in draw.io. And this was a good thinking of further optimization. So at the first level of bucket, you are going to categorize everything in a similar way, which would be now we are talking in terms of nested hashing. Hash inside the hash for faster retrievals. So first you have smaller buckets of map. This will be your categories. So imagine this is 101 book, this is 102. Now inside it you will have small hashed direct key map. So you just say key and then you will get the value, key and value. So you just give the book name and you will get the value. If you are not doing this, then all the books which lies here will sit inside a list over here there. So instead of iterating the bigger list, now you are trying to iterate over the shorter list. But if you further want it to be direct approach, that you just give it the ID or whatever the uniqueness it should come up, then you might consider using another nested map. So you will have, instead of list, you will have smaller maps. So your retrieval would be much more faster. But it takes the cost, because the more number of maps you create, more space it is going to take. So it comes at the cost. So this bucket and this bucket could be a list in some way, and this could be a map inside a map. So it's a trade-off. If you want that, you will get faster response, but you will have more memory footprints. Mohan, any question? Would you like to implement it in the inner nested map way today?
Okay, sir. I'll do it, sir. I'll do it.
Yeah, try it, and if it doesn't work or anything, I can help you out in implementing this. It should be straightforward. Just whatever we make it as a list here, instead of putting it inside a list, you need to keep it in the map. And you can make the key as probably the book ID, because book ID is going to probably might remain unique, or the title.
Okay. Okay.
Okay, let me first try to run this. So our program compiles, finds, and runs fine. So Naren, Spurti, do you have any ideas how we can do this instead of doing the repetitive stuff?
No, sir. Actually, like, I'm not that familiar with hash tables and all this stuff. Like, I know a bit about hash map and tree map, but I don't know about hash tables.
Okay, so the API would help, because in future you will face some problem. All of a sudden they'll give you something custom made framework collection internally built by some of the Fundu architect in the company, and then they'll give you solve it. If some situation will come next time, you might have to go to the core class of that. So like here. And from here we might have to try out, and if it contains key contains value, something like that, and then we'll figure it out. So at this level it is very it is not expected at all, but just in future, you have just to get familiarization, just go into the code, what is written over here, what are the different APIs which are available, what we can use it, and based on that we can try it out. Fine. So now what we will try to do, it's super simple basically. So we do not want these three different loops. We want it in a generic way. So first thing is we need to get the entry set. So this is probably going to provide us these three entries, whatever we have put it here. Then we will go through the same entries, and then we will just do one nested stuff for the books, and that will do everything for us. So we'll just try to go and grab it from the history. So another thing which I want to show you is the git history. From the git history also you can get that. There is something called as annotation. I'll tell you just a moment. So this one was our last version, and we were trying to traverse it in this way, right? So you can see what changes you made, and when we need it, once your program was running fine and then you screwed it up and you don't know what changes you made. So that command git if what we learned before, this is the same, but this is very comfortable to compare the code, what things were changed. So this we were not using before. Now we'll just try to leverage, modify it a little bit, and then it will help us to move faster. So we are trying to traverse the map. Now what we did is we have a simulated map, entry map. So you will get the entry set. Now what kind of entry set it is going to be, right? So we will go with the signature. So now this will give us the basically whatever the entries were there. So once we get the entry for this, this is our integer. Just a moment. So this is supposed to return us the keys. Leave it, I think it might not fit in. So technically what might happen is this is a set and it might have three values. All these three values would be sum of these 101, 102, 103, and each value is going to return us a list, basically some kind of list. We might have to go step by step. Just a moment. So what it is trying to say, it is saying incompatible types required java.util.map and found java.util.map.entry. Okay, let's leave everything. Let's go here. So we'll get the entry set. Whatever the values for the set, that will come over here, and that is going to be the integer basically. So we will have to have the set for this. So what is it giving is 101. That would be the first. Then it is giving us a list of 102, and then it is giving us a list of 103. It is giving us the key and the value of the set. Now we try to think what it is trying to give us is, okay, this is required is com.premasim.collection.book, and it is giving us the list of integers, seems like. No, this is giving basically entry set. Entry set is giving us a entry map with the, okay, so it is giving us this. Okay, what we are going to do is, so there is some syntactical sugar which is required. So I will finish this after our class, and then I'll push it so that we can move ahead to the next topic, which is the multi-threading. But on high level, what we need to try, basically I'll just share the algorithm and then I'll share the implementation later. Is first we will try and we'll go through the map, and there would be some method which would give us the all these basically lists, basically all these buckets. So then we will try and get the list from the each bucket 101, 102, and 103. Once we get the list from each bucket, right now we are having these three, so we'll delete all these three. Somewhere here we will say retrieve the list from all the retrieve the list from all the buckets of hash map. That would be stuff number one. And second is, we will have a loop. Let me just write a pseudocode. Loop over the generic method for all buckets. So if there are right now there are three, if there are, let's say, 10, so instead of writing 10 for loops, you will just do one for loop, and then there would be a return list, but the value of this return list will get changed based on the whatever the values are coming up with the hash map. So this is the algorithm code I'll push, and then you can run it on your local, and then we can look into it. There is some syntax, I just need to figure it out. I have to go to the map class, and it will take some time because it is trying to capture some exact signature which it needs. It's not that straightforward, so I'll set it up beforehand and then we'll move on. So now we have about 1 hour and we have to start understanding about threads. What is multi-threading? And this is a very important topic in terms of understanding and interviews. However, usually people do not write more multi-threaded programs. They'll go with the process like the normal programs more likely than the multi-threading. But if you know Java, basically people expect you that you know multi-threading and they will ask some question. If you are able to answer them clearly, it's like a added benefit. So what is multi-threading in Java? Multi-threading in Java is a process of executing multiple threads simultaneously. Thread is basically a lightweight sub-process, a smallest unit of processing. Multiprocessing and multi-threading both are used to achieve multitasking. But we can use multi-thread than multiprocessing because threads share a common memory area. They don't allocate separate memory areas, so saves memory, and context switching between the thread takes less time than process. Multi-threading is mostly used in games, animations, etc. So for the person who is reading it first time, it will be very confusing. So we might have to take some real life example. So let's say you are trying to talk. That is your one thing. You're just talking. And meanwhile, when you're talking, you also start eating. You have some chocolate or something. So you are able to do two things. You're talking and you're eating. Meanwhile, someone sends you a text or a message on your cell phone. So you will try to start reading also on your cell phone, whatever is being message is coming. So technically you're doing three things, but three things are different. For example, when you're reading, you're just reading one thing at a time. You're not doing anything else. You're focused on reading. Second, if you're eating, you're only eating. And third, when you're talking, you're only talking. But if you see that there is bandwidth and you can mix and match. For example, so it is again, very context specific. Context means if you want to study really focused, then it is something else than if you are just reading a joke on a WhatsApp or something. Then it doesn't need your full attention. Or if you are trying to read any instructions, navigation or something. So, if you unnecessary try to do multitasking or multi-threading wherever it's not required, you will end up having bugs, performance issues, complications, and everything. So, before implementing anything, we have to understand the cause and the effect relationship for wherever it is. So you are eating and then you are reading some jokes and then you are talking. And if you want to add four more things that you're driving a car with all these things, it might become complicated that you are already trying to manage so many things while you're driving also. But on the some other context, yes, it can happen. People do it oftenly. They are driving the car, they are trying to read their GPS instruction, and they are also talking to the person who is sitting which way we need to go, which way we don't need to go, and they can have a chocolate in their mouth. So typically it will not happen where you have your rice and everything, you're eating your rice and you're also driving, and your steering will get messy with the rice and curd and everything. That is a stupid scenario. So some programmer unnecessary try to put multi-threading wherever they want to, and it causes accidents. So just have this fundamental very clear that it depends on the situation where you need it and where you don't need it. Now, if there are some lightweight processes which are non-blocking, which can happen in multiple ways. So we will understand about this is multitasking. By the way, whatever I am telling you that you are doing not one task at a time, but you are doing multiple tasks at a time, and they are lightweight, can work in conjunction with each other. Now take an example of a puppet show. I am sure you might have seen the puppet show sometime before. So a puppet has to run, and then it has multiple threads in a puppet. So the whatever the talented guy, I don't know the exact name, the talented guy who is making the puppet dance, he has multiple threads on his finger. So he has one hand. You can imagine one hand is one process, and one hand has multiple fingers. So each finger, he can say, they are multiple threads, and each finger is having one thread typically with the puppet, and he is trying to make it dance at the same time. So one thread does not need much of the, you know, focus or area or blockage or whatever. Once he strings it, and then he's back. Then he so things to understand is how much resource we have so that it can be shared across easily and evenly. That's how you can do this kind of stuff. If you say okay, bodybuilding, so you are trying to lift, so that is a bad example versus the good example. So puppet show, puppet is lightweight, you just need some coordination and light bit of the processing which can happen. But if you see, okay, in the gym you have three things: you have bench press, you have to lift 100 kg of weight, and then you have to also do the cycling. Now you try to make, okay, let's combine everything. So the bodybuilder is sitting on the cycle, he's doing cycling, and then he's lifting 100 kg weight and also try to do some kind of push up. So that's a hayok that can, might happen, might not, but that's something bad. So it's a process that you are trying to resolve. It needs a lot of resources when you are trying to lift a weight. You have to have the focus, concentration. It can hurt you, right? So it it's a separate process in itself. Now let's try to read. These are just some kind of real example which I just took. So multitasking is a process of executing multiple tasks simultaneously. We use multitasking to utilize the CPU. Multitasking can be achieved in two ways. First is process based, and second is thread based. Process based multitasking, each process has its own address in the memory, that is, each process allocates separate memory area. Process is heavyweight. Cost of communication between the processes is high. Switching from one process to another requires some time for saving the load registry, memory maps, and updating lists, etc. So you can think of this as your main process. So your process gets exited here, and whenever you're trying to run, this is a main process. So in the computer you can run three programs simultaneously, it will not stop you. But each process is heavy. So you say eating is your program, and reading is your program, and talking is your program. If you will try to run three processes, then the process will be heavier basically. So you can write one program inside which you can have three smaller modules, and each can be spun as a thread. So we will try to do that. So thread-based multitasking, thread shares the same memory address, thread is lightweight, and cost of communication between the thread is low. So when I'm sitting here, I am able to coordinate very well with these lightweight threads of talking and teaching and eating or whatever. So this is a one process wherein I am here. However, these separate processes could have been, just imagine that I have to go to kitchen and then eat, and then I have to come back and then I have to talk. And once I'm talking, what were three things we were eating and reading? Yeah, and then I have to go to library and read. So these are three process: read in library, eat in kitchen, and then talk with the friends. So three process, there is lot of context switching, and that's why if you combine them, so I am sitting here, I am talking to, and I am eating chocolate. If the same memory address is here, and I am trying to do everything as multi-threading, some when I am, let's say, eating, so for a while I can stop, I will not talk. I can so thread can go to another state which is called as sleeping. and then it will be awake, it can join, it can heal. So we'll learn that later, but just I'm giving an example that three different process, how process works. If there are three locations of doing the same thing, read in library, eat in kitchen, and then talk with friends on the drawing room, rather than doing everything together. If it the context switching does not require much, then it becomes the multi-threading. You're trying to do multiple tasks. The thread is lightweight sub-process, a smallest unit of processing. It is a separate path of execution. Threads are independent. If there occurs exception in one thread, it doesn't affect threads. It shares a common memory area. So we learned this. Let me just start another recording so it can be separated out.